Okay, so in this key, you're solving exponential equations, and in this case, you're going to solve this by expressing each side as a power to the same base. So you want to solve this using the same base. You don't want to solve it using logarithms. Okay, you want to solve, in this case, using the same base. All right, so you want to rewrite these bases with the same, with this base here and this number here, 64, using the same base. All right, so if you look at 64, you see this 4? Let's see if I can keep the 4 here. If I can keep the 4. So let's see, 4 to the third power is 64. So I can rewrite 64 as 4 to the third. So I'm going to use base 4 here. So I'm going to say 4 to 2x minus 3 equals 4 to the third power. And now I'm going to use the one-to-one property. So remember the one-to-one property. One-to-one property for exponents. And so basically that says when the base is the same, the exponents have to be the same. So this exponent has to be the same as that exponent. All right, so this has to equal this. So so it's basically the same. I'm going to set these exponents equal to each other. So I'm going to get 2x minus 3 equals 3. And then notice I went from a exponential equation to a linear equation. So this is linear. So I'm going to add 3 to both sides. The combined like terms, I get 2x equals 6, and divide both sides by 2 to get x by itself. I get x to be 3. Okay, so x is 3. Okay, over here, this base is 3, this is 27. So since 3 is prime, let's go ahead and see if I can rewrite 27 with base 3. And notice I can, because remember, 3 raised to the third power is 27. So that's what you want to use. So I'm going to say 3 to the x minus 1 equals 3 cubed, and that's raised to the x power. So notice, write it like this first. And then remember in the previous course, a power raised to a power you multiply, so using the power rule. So I get 3 to the x minus 1 equals 3 to the, and then that becomes 3x. Okay, so that's where I'm at. So now I can use the one-to-one property for exponents. So since the base is the same, the exponents have to be the same. So that means that x minus 1 has to equal 3x. And then let's, this is linear now, so we went from an exponential to linear. So let's go ahead and just bring the variables to the right-hand side. So I'm going to subtract x from both sides. Combine like terms, I get negative 1 equals 2x, and then you get x by itself, and divide by 2, and so therefore x equals negative 1/2. All right, so there's the value for x. Okay, number 3. This is 16, this is 8. So you may say, well, can you use 4 like I used 4 here? The answer is no, because although you can write 16 as 4 squared, you can't write 8 as 4 to a whole number, or 4 to an integer. All right, so you got to think, well, now let's look at prime numbers. Is there a prime number that I can use for both 16 and 8 at the same time? And the answer is yes, 2. So 2 to the fourth power, if you look at this, 2 to the fourth power is 16. So first thing you're going to do is going to write 2 to the fourth here. So the 16 you're going to rewrite. But remember the 16, this is 16, is being raised to the 3x minus 1 power. So you have to write it like that. Equal, and then 8, remember, is 2 cubed. And so 2 cubed is now being raised to the x plus 5 power. Don't forget, 2 cubed is still 8, and 8's being raised to the x plus 5 power. Now, just like we did this, you have to get rid of the parentheses now. So notice I did have to use parentheses here. Make sure you use parentheses so you don't make some kind of error within the process. Now, when you remember the power rule, when you have a power raised to power, you multiply. So right here I have 4 times 3x minus 1, so keep that in mind. So this times this, so that's how it's supposed to look. And then you distribute, and you get 12x, and then minus 4. So that's going to be 2 to the 12x minus 4 here. So 4 times 3x minus 1 is 12x minus 4. Equal, to do the same thing here. That's going to be 3 times x plus 5. And so when I distribute, I get 3x plus 15. So that's going to be 2 to the 3x plus 15. Okay, so now the base is the same, so now the exponents are going to be have to be the same. So I'm using a one-to-one property for exponents. So then I'm going to say 12x minus 4 equals 3x plus 15. And then I'm solving this linear equation, so subtract 3x on both sides. So 3x minus 12x minus 3x is 9x minus 4 equal, this is 0 plus 15. and then adding 4 to both sides and combine like terms, I get 9x equal 19. And so then I divide both sides by 9, and so I found x to be 19 divided by 9. Okay, so there's your solution. Alright, so notice that in this worksheet, though, you make sure you follow directions. Direction says get the base to be the same, then that's the way you do it. Alright, so that's going to take care of worksheet 4.4, part